So hopefully finishing that paper from last class made you realize that numbers in our absolute value function change the function, either moving it or making it wider or narrower. Hopefully you figured that out. Depending on where those numbers are located means something. So, did you figure out if a number is in front of the absolute value, what happens to your graph? Good. Yeah. Oh, that's a good word. Stretched. It gets narrower or wider. And this is actually called a vertical transformation. So for A, I want you right here to write vertical. A is your vertical transformation. Now, if we're thinking about this like, I know it's hard to visualize, but pretend this, and it's hard to see, pretend this rubber band is your graph, okay? And I am changing it on the vertical. So I'm taking my hands and either stretching them apart or compressing them. So when you stretch or multiply it by a number bigger than 1, what happens to the graph? Yeah, it gets narrower. So this is called a vertical stretch. When the number is bigger than 1, it's a vertical stretch. When I, instead of stretching, I push my hands closer together, I'm compressing, what happens to the graph?
It goes wider.
It gets wider, right? So when I'm compressing on the vertical, the graph gets wider. And this happens when the A is what?
Is less than 1.
Good, less than 1, or in other words, a fraction. So let's write that. When A is greater than 1, it's a, what did I call it?
Stretch.
It's a stretch. So when A is a whole number, it's a stretch. And when A is less than 1, what is it?
Compression.
A compression, good. Does anyone know maybe why I put the A in absolute value? Why would I do that? Yeah, it's a variable. Yeah?
Because you have to do it to both sides?
Not quite. So think about, what else did you see that could be in front of the absolute value? Not only a number, but a what?
Negative.
Oh, a negative sign. Did anyone figure out what the negative sign does to the graph? Yes, beautiful terminology. It is a vertical reflection. So when A is negative, it's a vertical reflection. So the reason I put the A's in absolute value is the negative does not determine stretch or compress. What the negative does is it reflects it. So if I had a -2 for A, it would, yes, be a vertical reflection, but it is also a vertical stretch. It is two things. A vertical stretch of 2. The next letter, B, we are actually not dealing with in this unit, but I do need to introduce it to you. B is your horizontal transformations. Horizontal. As you can see, B is inside the absolute value, and I'm going to tell you right now, anything inside your absolute value is always going to be backwards. So horizontal is inside the absolute value, it's backwards from vertical. So if I'm thinking, I can't really do it with a rubber band, but if I do it with my arms, we're, instead of stretching and compressing on the vertical, we're stretching and compressing on the horizontal, like this. So pretend my arms are the graph. If I am now stretching my hands apart, what happens to the graph? It gets wider. Is that what happened before when I stretched? Did it get wider on the vertical? Remember when I stretched my hands like this, it got what?
Deeper.
Narrower. Good. So it's backwards on the horizontal. When you stretch, you're getting wider. So, well, not A. When B is greater than 1, before it was a stretch on the vertical, what do you think it's going to be on the horizontal? Compression. Compression. And when B is less than 1, it's a stretch. So again, if I'm stretching my hands apart on the horizontal, I'm getting wider. If I'm compressing my hands together, I'm getting narrower. So it's exactly opposite. Yes,
But don't they like look the same on a graph?
they do. And that's why it gets tricky, and that's why we're not touching it this unit. Don't worry. It'll be okay. And also, I just want to say that when we do get into horizontal, it's backwards. So if, say, this was, B was 1/2, you would say that it is a horizontal stretch of 2. But don't worry, we're not getting into it yet. Just wanted to forewarn you. So next, we have H and K. What did those two things do to the graph? Did it change the slope?
H changed the x, and then y, K changed the y.
Right. Or what is a geometry term for sliding something on a graph?
Translation.
Ah, both of these are translations.
The H is backwards.
Right. So, remember I said anything inside the absolute value is backwards from what you would think. So, if H is negative, where do you think it moves on the x-axis?
Right.
It moves to the positive direction. So when H is negative, it's a negative H, it moves right. And when H is positive, where does it move? Left.
But isn't that only when it's in parentheses?
No. No. So, for example, if I had x minus 2, like that, that graph moves to the right. Mm-hmm.
And if there's not that, it still moves to the right? Or if it's
So,
only if it's in the
in the absolute value.
absolute.
Inside the absolute value, yes.
Okay,
If it's outside, what happens?
It's opposite, right? Because it's vertical.
Up or down. Good. When we're moving K, we're moving up and down. And this is normal because it's outside. So if K is positive, where does it go? Up. And when K is negative, where does it go? Down. So inside the absolute value is backwards from what you think. Everything outside is normal. When A is less than 1, it's a what?
Compression.
Compression. Less than 1 is a compression. When K is a positive 6, what happens?
Goes up 6.
Perfect. When H is negative 3, where does it go?
Moves to the right. Moves to the right.
3 to the right. When A is minus 2, what does that mean?
It's reflection.
Reflection and
Twice as stretch.
it's a vertical stretch. Make sure you're using that vertical word. So it's a vertical reflection and a vertical stretch. Any questions on this? Okay. So, pause.